This is a video that's going to explain how to use a graph to solve linear equations. Now, we know that many people know how to solve linear equations by hand, and we've already studied that. What we're trying to do now is see the connection between those techniques and graphs. So first I'm going to explain how to come up with the solutions from a graph, and then I'll tie it into the solutions that you can get by hand. So the first method that we could use is called an intersection of graphs method. And basically what that means is that we're going to use each side of the equation to create a separate graph and then look at the two together to come up with the solution. So what I'm going to do is I'm going to take this left side of the equation and I'm going to call that one of my y values, or y equations, and this one is my second one. So I'm basically taking one equation and I'm splitting it into two. Y equals 2x plus 5 and y equals negative 3. Now if these equations are fairly straightforward, you can use what we know about slope and intercept to come up with the graphs. So y equals 2x plus 5, that's going to have a y-intercept of 5 and a slope of 2. So I'm going to put some dots here on the graph and I'm going to draw that line in. My freehand graph on a tablet computer isn't very straight, but if you were doing this on paper you could use a ruler. And then y2 equals negative 3, that's a horizontal line down at a y value of negative 3, so that's this graph. And the solution, well, if you look at the original equation that you're given, this equation right here, that equation only involves an x. So my solution is going to be an x value, but it's going to be the x value where these two y values are exactly the same. So if you look at your graph, the only point where the x and y values on both graphs are the same is the point of intersection. You'll notice that this point right here has a y value of negative 3, and the x value is negative 1, negative 2, negative 3, negative 4. So the point of intersection is negative 4, negative 3, but the solution to my equation is just the x coordinate because that's the only variable I had in my original equation. And notice if you plug in negative 4 right here, 2 times negative 4 is negative 8 plus 5, that is negative 3. So when you're using intersection, the solution is the x coordinate of a point of intersection. The other thing people do is they often use an x-intercept method. And so what that means is you take the original equation we had, which was 2x plus 5 equals negative 3, and instead of creating two equations, you just create one, but first you make the equation equal 0. And the reason you make it equal 0 is if you think about an x-intercept, we know that for an x-intercept, the y value has to equal 0. So if I take this and I add 3 to both sides, I get 2x plus 8 equals 0. So I could create just one graph of y equals 2x plus 8 and then look for the x-intercept. So 1, 2, 3, 4, 5, 6, 7. Oops, I don't even have 8 on my screen. There's 8 there, and if I had a slope of 2, I can't go up because I would go off the screen. But here are the points that have a slope of 2, and I draw in this line. Again, if I wasn't doing it freehand, I would use a ruler. And the solution, because now I have this thing equal to 0, my solution is the x value that makes the output 0. In this case, it's right here, which is a value of x equals negative 4. Now you might ask yourself, geez, with an equation 2x plus 5 equals negative 3, why would you go through all the effort of making a graph to come up with the solution? Well, it becomes clearer that it might be more beneficial if you start having equations that involve a bunch of fractions. So if I wanted to do this one, negative 2/3 x plus 3 equals negative 1 using a graph, if I did the intersection method, I would create two different equations. Y equals negative 2/3 x plus 3 and y equals negative 1. Well, y equals negative 1, that's just a horizontal line down here at negative 1. And y equals negative 2/3 x plus 3, using slope-intercept, it's got a y-intercept of 3, which is right here, and a slope of negative 2 over 3. Remember, negative 2 is the rise, 3 is the run. And pretty quickly those lines cross. That's better. Pretty quickly those lines cross, and I can see that that point right there has a y-coordinate of negative 1 and it's got an x-coordinate of 6. So my solution is the x-coordinate, x equals 6. If I wanted to use the x-intercept method, I could make this equal to 0. If I add 1 to both sides, I'd have negative 2/3 x plus 4 equals 0, and I would graph this line, y equals negative 2/3 x plus 4. So it's going to be a different line. I'm going to go up here to 4, and then I'm going to go down 2 over 3, down 2 over 3, and draw in my line, just a little bit different than the line I had before. And because this is equal to 0, the solution is the x value, x-axis. So again, this is x equals 6. So you get the same solution either way. Some people might like graphs better than clearing fractions from equations. Okay, last one. Solve 1/2 x plus 1 equals 5/6 x minus 1 using a graph. Which method is easier for a graph? Well, when I look at this, I think I either graph two separate equations. They're both in mx plus b form, so that's not too hard. Or I could pull everything to one side and make it equal to 0. But if I were going to pull everything to one side and make it equal to 0, I'd have to add or subtract some fractions, which I can do, but it will take me a little bit longer. So I'm just going to treat these as two separate graphs, y1 and y2. I'm going to look for where they cross. So the first one, 1/2 x plus 1, that's got a y-intercept of 1 and a slope of 1/2. So let me draw that one in. And the second one has, this one here has a y-intercept of negative 1 and a slope of 5/6. So 1, 2, 3, 4, up 5 over 6. That's right there. So if I draw that line in, I get that. And there's my point of intersection, which if I was using paper and not a slippery tablet, it would probably land exactly on that coordinate. 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4 up. So this is the point 6, 4, and remember that the solution is the x-coordinate. So the solution is just x equals 6. And notice that if you take that solution, x equals 6, and you plug it in, 1/2 times 6 plus 1, does that equal 5/6 times 6 minus 1? If you evaluate this, half of 6 is 3 plus 1, that's 4. 5/6 times 6, those cancel out. That's just 5 minus 1 is 4. So they really are equal. So 6 really is the solution here. Notice this thing that I get when I check this solution on each side, 4. That's that y-coordinate right there. That's how you solve equations using a graph.